Today we're going to talk about electromagnetism. I guess most of the time when we want some electricity, we just plug a plug into the wall and electricity magically comes out. But through electromagnetism, we can create electricity, and actually we can understand where most of the electricity that comes out of that plug in the wall actually comes from. So I have here some very simple things. I have a magnet. Now this magnet's actually made from the element neodymium. And that means it's a really strong magnet, but the idea is just the same as any magnet you might have on your fridge. I have some wire. This again is just like wire that might be connected to any appliance at home. It's a tin copper wire and it's got some plastic around it for insulation, and it conducts electricity really well. And the other thing I have is a multimeter, and this will enable us to measure any currents that we create. I'm going to turn this around to a microamp setting, and that means it's going to be able to measure really, really tiny currents. So the first thing I'm going to do is connect the ends of my wire to the terminals of the multimeter. So I've already looped my wire into coils, and I've left the ends out here. So I'm just going to attach these to the multimeter. I'm going to shove them in some pieces of blue tack here just to help them stay connected, because I don't have quite enough hands for this. So that's one end connected to one terminal and the other end connected to the other terminal. Great, and so you can see my wire is connected to my multimeter, but the multimeter is measuring zero. There's no current running through the wire, and we wouldn't expect there to be. There's no reason for there to be any electricity flowing through it. But I'm going to do just a very simple thing. I'm going to take my magnet and I'm going to put it inside the coil of wire and just watch the numbers on the multimeter to see what happens. So as soon as I move the magnet inside the wire, those numbers on the multimeter jump up. And we're getting values up to a few tens, maybe 20, 30, 40 microamps on the multimeter. If I put the magnet inside and then hold it as still as I possibly can, we see those numbers drop down. And if I was holding it completely still like that, then they're actually at zero. And when I start moving it again, then they jump up. So this is already telling us something amazing. Just the simple act of moving a magnet inside my coil of wire means that a current starts flowing in that coil of wire. We've just created electricity just by moving the magnet in the coil of wire. I think that's actually amazing. We can see that it's only when we're moving the magnet that the current flows. When the magnet stops, there's no current. We can do a few other experiments to test out exactly what's going on here. So we saw those numbers being at 40 or so microamps. If I move the magnet much more slowly, let's see what happens then. So now we're still seeing some current is flowing, but it's much less. We're down now to only a few microamps. We're less than 10 microamps flowing through the wire when I'm doing this. So the magnet has to be moving, and the faster that it's moving, the more current that we get. We can do a couple of other things. Here I do actually have just an ordinary magnet from my fridge. So let's see what happens if we use this instead. So if I move this in and out, now at quite a fast pace, again, we're getting some current flowing, but it is tiny. It's mostly less than 1 microamp, at most getting up to just 1 or 2 microamps flowing through it. So a weaker magnet still produces a current, but it's much smaller. Another thing we can do is produce more loops in our wire. I'm just going to fold this in half, and now all of a sudden I've got twice as many coils of wire. We go back to our original strong magnet, and I'll move that in and out again. And now let's look at what those numbers are doing. They're jumping all over the place a bit, but they're getting up to much bigger numbers. Before we were at 30, 40 microamps. Now we're getting numbers over 100 microamps. We're getting up to 200 microamps flowing through the wire. So stronger magnet gives us a bigger current, and if we have more coils in our loop of wire, we have a stronger current as well. And that's really the principle of electromagnetism. That's all it is, that if we have a magnet moving near a conductor, then it will induce a current in that conductor. And that's actually explained by this equation, by the Maxwell-Faraday Law of Induction. So in this equation we have a B, and that's our magnetic field. We have our magnet, and around that magnet is our magnetic field. And we want that magnetic field to be changing with time, and that's the T in the equation. So where we have the dB by dt, that's telling us that our magnetic field has to be changing with time. And if we have that, then on the other side of the equation we have E. That's our electric field, and that's associated with our current in our wire. The upside down triangle and the cross with the E is the curl of the E, and that describes how our electric field behaves in space, and tells us that it actually really curls around that magnetic field. And that's why our current flows best if we have loops of wire going around our magnetic field. So you can see if dB by dt is 0, if there's no change in our magnetic field, our magnet's just sitting stationary, it's not changing, then we don't get any current induced. But if we have a bigger dB by dt, either by moving our magnet more quickly or having a stronger magnet, then that's what gives us a bigger current. It's actually a really simple principle, but it's so important, and it's been revolutionary for humanity. This is really what enables us to create most of the electricity that we have. Whether your electricity is created through a wind turbine or a hydroelectric plant or even a coal-powered plant, we're using that energy really to move massive magnets inside enormous coils of wire, and that's what creates most of the power that would come out of that socket in your wall. So that's electromagnetic induction. Amazing, revolutionary, and not actually that difficult to understand. Thanks.